change. So here, the first change is you do MPI win allocate, and you use you allocate it for two of the arrays. For both of the arrays are allocated at once here, and the new and old arrays, just the offsets are calculated. Once is starting at the address, and the other is that plus the grid size. So these are the two arrays we switch between in each iteration. Rest is the same. The type vector and commit is the same as in the I send, I receive example. Then the difference comes here. You replace the I sends and I receives with the fence call. You put a fence across the two, and the rest is just you're doing the puts to the north, south, east, and west neighbors. The only things you have to be careful about is now the actual address that you're passing. So this is at 1-1. When you're sending it north, it's at 1-1 in that old array. And then if you're sending it south, it's at some other location, and east and west. And then the address, the location in the target is the other thing that you have to be careful about. So that is just index calculation, just something tedious that in a short amount of time you may not think of it correctly exactly. It might be off by one or something else. But as such, it's easy. Then you do the fence. That's when all these operations are over. Then the rest is the same. The swapping of old and new and everything else is the same. So, and as such, it's easy. The other example which does the get is also, I hope it's here. Let's see. Fence. Yeah, the get is the same. It's just the buffer addresses are different. Everything else remains the same. You need to provide the right address for where the data you want to receive into, and the right offset and index in the target from where you're going to get that data. And if you're doing a north-south type of thing, the data type is just MPI double. If you're doing east-west, then you have the vector type as the data type. So it's easy. Any questions? Yeah, one question is, why don't we have the north-south types? Because the north-south are contiguous. So, and somebody has replied, yeah, it's because they are contiguous. In the first step, it was just used as an example to show how the type contiguous is created. But if something is contiguous, you don't need a data type there. Yeah, you can submit jobs to Cooley after 4 p.m., I believe. The reservation might end at some point, but it'll just take a little, it'll run through the queue.
Okay, so that's partially true.
Okay.
So the reservation goes through 6 p.m.
Yeah.
And if your job does not start before 6 p.m., right, the reservation queue name is training. You'll have to move it into the regular queue, otherwise it won't run it until the next time, the next morning.
And
So you can
what's the name of the regular queue?
Just default, I think.
And is there an interactive node or something where you can just run?
Well, you can submit an interactive job on one node and then keep doing things on it. That's how any of them work. You shouldn't run on the login node. So if you let me know offline if you would like to try to extend the reservation or in a smaller number or whatever.
Okay, Janfe is restarting his Zoom, so we have a couple of